The distinction between how old you are and how old your biology is turns out to be clinically profound, and the tools to measure that distinction are becoming accessible at a pace that will force medicine to confront it. The epigenetic clock concept, specifically, the measurement of DNA methylation patterns across the genome, represents one of the most powerful biomarker developments in aging research, with implications that extend far beyond longevity science into insurance, employment, and the fundamental question of how risk is understood and priced. The basic finding is this: the pattern of chemical modifications on DNA, specifically methyl groups attached to cytosine bases, changes with age in a remarkably predictable way. Steve Horvath's original methylation clock, published in 2013, could predict biological age from any tissue type with striking accuracy. Subsequent generations of clocks, Grim-Age, Dunedin-Pace, PhenoAge, have been refined to predict not just how old someone's biology is, but how fast it is aging and what their risk trajectory looks like for cardiovascular disease, cancer, and all-cause mortality. The key clinical insight is that two individuals of identical chronological age can have dramatically different biological ages, measurably so. A 40-year-old with a biological age of 50 and a 40-year-old with a biological age of 32 have genuinely different risk profiles, different expected health spans, different clinical trajectories. Treating them identically because their birth certificates say the same thing is a form of medical imprecision that the epigenetic clock makes unjustifiable. The positive applications are genuine. Clinical risk stratification based on biological rather than chronological age will improve the targeting of preventive interventions. Drug trial design that recruits based on biological age rather than chronological age will produce more homogeneous study populations and more generalizable results. The ability to measure whether a lifestyle or pharmacological intervention is actually slowing the methylation clock, rather than just making someone feel better, creates a genuinely objective endpoint for anti-aging and longevity medicine. Here is where the warning must be issued clearly. The insurance industry's interest in this data will not be benign. An insurer with access to an individual's epigenetic age profile has actuarial information of extraordinary precision. A life insurer that can identify applicants whose biological age exceeds their chronological age by 10 years, predicting significantly elevated mortality risk, will be under enormous commercial pressure to price those applicants out of coverage or deny them altogether. This is genetic discrimination by another name, and it will require robust legislative responses before the testing becomes mainstream. The history of genetic information in insurance markets is not reassuring. Without legal protections equivalent to or stronger than those provided by GINA, the Genetic Information Non-Discrimination Act, epigenetic data will be weaponized against exactly the population it is most clinically useful for identifying. The science is ready. The governance is not.